rational exponent notes. So like we said before, a rational number is a number that's a fraction. So these are exponents that are fractions. Okay. If I told you, for example, 4 to the 2/3, right? It's got a fraction, right? That's an exponent. What it means, though, right, is there's a little shortcut called power over root. So the 2 is actually the power, and the 3 is the root. So this is the power, and this is your root. So when you write the number out, okay, you're actually going to say 4 to the second power, and I want the cube root of that. Power over root. The 3 is the root, see? And the 2 is the power. Okay, so power over root. So in other words, you can maybe think about it like this. You know, it's 4 squared, and then the cube root. Maybe that'll help you see it. Whatever works. Right. Let's try a cube. The first set of directions is to evaluate. 36 to the 1/2 power. So what's my power here, guys? 1. Does the power of 1 do any changing? No. Okay. And what's my root? 2, which is just a what? Okay, so this is a power of 1 over a root of 2. So whenever someone asks you something to the 1/2 power, they're just saying what's the square root of that number. That's what that means. So this is just the same as the square root of 36, which is 6. Number 2. Okay, it's going to say 64 to the 1/3 power. (64 to the 1/3 power. Power over root. What's the cube root then? Oh, by the way, speaking of roots, on your quiz on Monday, right, the roots that we've been looking at all week on the board won't be there. So you have to have them memorized. But hang on, listen though. I know some kids have them memorized, but they just kind of like visually seeing them. So my advice would be on the quiz, right before you start your quiz, just kind of list them really quick. And then you've got a printed version of them so you can look. Maybe that's a good way of looking at it, okay? So that might help you. In other words, on the quiz, you can just write down the ones you know, then take the quiz. So this is actually asking for the cube root of 64, which is what? Number 3. 49 to the negative 1/2 power. What does a negative do? A negative does what to it actually? It flips it, doesn't it? Okay, it actually flips. Okay, or it tells you where to put to put the number in the denominator. In other words, if your number's in the denominator, it needs to go where? Into the numerator. If it's in the numerator, it needs to go to the denominator. It flips it, doesn't it? Isn't that what a negative does? So you have to take care of the negative first. So this is actually not 49, but what? 1 over 49 to the 1/2 power. Well, it applies to both. The 1/2 applies here and here. We've learned that, haven't we? So, and we know that's power over root. So I'm looking for the square root. What's the square root of? So I'm looking for the square root of 1 over the square root of 49, which is 1 over 7. Number 4. 1/8 raised to the negative 1/3 power. What's the negative going to actually do to the 1/8? It's going to flip it and make it 8 over 1, or in other words, just 8. So you always take care of the negative first. So now I have 8 to the 1/3 power. Right? Remember, it's power over root. So 8 to the 1 power is 8. So we're really just looking for the cube root of 8, which is how much? 2. Number 5. Okay, this one's strange. This one we haven't had yet. What about 36 to the 3/2 power? Power over what? Root. And we are not allowed to use a calculator on this unit. So I don't know about you, but I do not want to try to take 36 to the 3rd power without a calculator, right? We'd be here a while, wouldn't we? So which one should we do first? What's going to make it smaller? The square root. The root will, right? So take the root first, and then you can do them in your head, okay? And it's a lot easier. So if you have one where it's not easy, just like we did before, we took the cube root, the square root, the cube root. Here, take the square root first. Write yourself a big note, okay? Take the root first. Take the root first. So in other words, I'm asking for the square root of 36, right? So what is the square root of 36? 6. Right? Okay, now take 6/3. Now use the power. What is 6 to the 3rd power, guys? 216. It's a lot better, isn't it? You do all of it in your head. Just take the root first. Okay? It'll make it easier. Number 6. (27) to the negative 4/3 power. What's the first step? Yeah, instead of using 27, what are we going to use? 1 over 27. Excellent. And then we're going to raise it to the 4/3. What was my little trick? Take the what first? Take the root first. What's the cube root of 1? 1. What's the cube root of 27? 3. And then what power are we going to put it to? 4. So 1 to the 4th power is 1. I almost said 4 earlier today. 1 to the 4th power is 1. And 3 to the 4th power is 7. I told you the fractions weren't too bad. Flip it first. So this becomes negative 1 over 27. Agree? To what power? 2/3. Take the root first. What's the cube root of a negative 1 over 27? Negative 1 over. Okay, the cube root of 1 is 1. The cube root of negative 27 is negative 3. Doesn't matter where you put the negative 3 as long as it's with one or the other, right? Now then, what power are we going to take? square, and so it becomes 1/9. That was a trickier one. 16/81.
What's that? Oh.
16/81 raised to the 1/4 power. I'm sorry. Is that better? What root are we finding? The exponent is just 1. Power is 1. So the fourth root. What's the fourth root of 16? 2. What's the fourth root? Or guys, you can look at it like this if you want. It's the same as the fourth root of 16 over the fourth root of 81. You don't have to write it out though, which is 2/3. Number 9. The negative flips it. My little secret was to take the root first, correct? So root first. What's the fourth root of 81? Well, 3, right? 3/2. Then you have to cube it. So we have to cube it. So you end up with 27/8. How do you feel about it? Pretty easy? Yeah, really is not bad at all. Okay? So now that we're going to switch gears a tiny bit, and let me remind you about 2 things. If I tell you a to the 1/3 power, that is in radical form, right? But if I tell you the cube root of a, we are, why did I say radical? I'm sorry. What form is that? I was jumping ahead of myself. Dang it. Yeah, rational, well, it's called exponential. I'm sorry, guys. It has an exponent. Exponential form. I was trying to rush. Okay, and then what form is this? There you go. Radical. It has a radical. Yeah, it has square root. Same thing, yeah. Okay, so they're going to sometimes give you directions, and they're going to tell you, be sure to write it in exponential form, or be sure to write it in radical form, right? Does that make sense? Okay, sometimes knowing what the vocabulary is helps with what they're asking us to do. So that's what they're going to say for directions. Let me switch the page here. So simplify and write the answers in radical form. In other words, they have to have a radical in them. Here's number 1. X to the 2/3 times x to the 5/3. What form is that in right now? Excellent. It's an exponential. Not really what we're looking for, right? Unfortunately, it wants radical form. So on that note, they have like bases. What's the rule? What if I told you x squared times x cubed? What would the answer be? X to the, yeah, 5th. So these have like bases. What can I do to the exponents then? Just because they look ugly doesn't mean the properties change. Right? You can add exponents, right? So what's 2/3 plus 5/3? How many thirds? 7/3. So it's closer, but still exponential. How do I turn that into radical? Power over root, correct? So it's the cube root of x to the 7.
Oh, yeah.
Remember, if the outside number is smaller, you can clean it up. So I'm going to rewrite this as x to the 6th times x. So what can I clean up? This will be x squared times the cube root of x. That's yesterday's. Number 2. How about a to the negative 2/3? The directions are right using the radical. Just like before, where should we start? Yeah, so it's actually 1 over a to the what power? 2/3. And 2/3 applies to both though, doesn't it? So what is 1 to the 2/3 power? 1. Yeah. And then a to the 2/3 power. But if you want, you can write yourself a little note. But really, we don't want that. We want it in radical form. So it's power over root. So the cube root of a what? Squared. Okay, I'm going to run out of room. So I'm going to take this over to here and talk to you about it a little bit. This is 1 over the cube root of a squared. Can I leave a radical in the denominator? I need it in radical form, but I'm not allowed to have the radical down here. This is, again, yesterday's notes, remember? So I've got it rewritten. What was my next step? Fill in the box, remember? So I'm using cube roots. So I'm the cube root here and the cube root here. How many a's do I have here, guys? 2. And I need to find a cube root. So how many more a's do I need? Good, I hear it. What? How many more? Excellent, 1. So whatever you do the bottom, you have to do the top. Okay, so if we clean this up, cube root of a squared times the cube root of a is the cube root of how many a's? 2 here and 1 here make 3. Excellent. And the top 1 times this just stays the same. What does the denominator become, though? The cube root of a just drop, please drop, and become a. Okay, we'll do more. By the time I do several more of those, you'll have it. Let's try number 3. How about a over b to the 3/4? Radical form. So I'm going to say a over, how am I going to rewrite this? Power over root, right? So it's the 4th root of b, power over root. So the 4th root of b to what power, guys? 3. Okay, so it's been rewritten. Now, according to yesterday, we're going to fill in the box so we can get rid of the radical in the denominator. It's the 4th root. So I'm going to take the 4th root on both. What do I need? Got 3 b's here. How many more do I need? 1 more. Whatever you do the bottom, do the top. Okay, this becomes 3 inside here and 1 here, so there's 4, right? If you skip this step, it's okay. I'm just showing you where it came from. Some kids don't quite remember where it came from. Now, what about up here? I'm going to take a second here. Remember, outsides, insides. So what's on the outside right now? An A. And what's on the inside? A B. And what does the denominator actually become? B. Okay. Sometimes you got to write that step for you to see it, especially in the beginning. The step's not necessarily needed. And you're good, right? Radical form, check. No radicals denominator, check. You're done. Okay? Try another one. If you have a fraction as an exponent in the denominator, it means you have a radical. So you can't have that. So clean it up. No radicals in the denominator. Okay. Four over power over root to the cube root of 3 squared. You can rewrite 3 squared as 9 and do it the way we did the other day. So you have to multiply 9 times 3 is 27. Gives you a perfect cube, right? Or you can kind of do it the way you've been doing it. If I have 2 3's, how many more 3's do I need? 1. So here it means I've got the cube root of 3 3's. Outsides, insides give me this. The denominator simplifies to 3. Oops. Be careful about your work. The 4 needs to be on the outside, the 3 needs to be up high. Does that make sense? Okay. We're getting close. We're only going into probably 9. So we're at 5 now. Well, I love y'all too. Number 5. We are going to. I can add more. Y'all want more? Oh, just a second. Sorry, my kids are hungry. Oh, you want to read 20? Okay. Now, same. These are the same now. You should be getting better at them. 14 over power over root. So it's the cube root of 7 squared. How many more 7's do I need? 1. Can I just put 7 here? Don't understand that that's 7. I skipped to that. We've done enough like that.
Yes.
I have two here and 1 here, so there's 3, so they cancel. So this is 7, agree? And then here would be 14 on the outside and the cube root of 7 next. And anything cancel.
Yes.
Right, those of you that are gone yesterday, I cannot cancel that 7 and that 7. This is the square root, right? So this is the cube root of 7, not 7. Right, 2 cubed is 8, so that's really about 2. Okay, can't cancel that. And just this. So the actual answer is 2 cube root of 7. This is the last one that's the same. And we're going to do 2 more that are different and we're done. And 3 more. What's the same as 3? The 1/2. Do you remember it now? 10 over square root of 3. Square root of 3 just means you multiply it by itself, right? You see 2 3's. So times root 3 over root 3. Which would be 10 root 3 over what goes in the denominator here. What's root 3 times root 3? Root 9, which is 3. Alright, so if you've tuned me out, now we're changing gears. You ready? These are different. So if I take 10 to the 1/4, a to the 9/4, and b to the 3/4. What were my directions? Do you guys remember? Write it in radical form. Agree? Those are not radicals. Those are exponents. What root are all of those, though? They have something in common. What root? Right. So if I'm asking you to write it in radical form, they need to all fit under the same root. Do they all fit under the same root? Yeah, they're all the 4th root. So then, okay, so let's build that. The 4th root of 10 to what power, guys? 1. Now move to A. A to the 9th. And then B to the 3rd. Can I simplify this? Yeah, if the 4 is smaller than one of these exponents, you can. Right? Now, that's a 4th root. You can't even with the 10. Okay? So I can with the 9, though. So let's rewrite this. This is 10. A to the 8 times A, and then B cubed. Can't do anything. So the only thing I can pull out is this. This becomes A squared. And else is stuck inside. 10ab cubed. Number 8, x to the 2/3 power, y to the 3/4 power, divided by x to the 1/3, y to the 1/4. Okay, what do we do when we have variables on bottom and variables on top? What do we do with their exponents? What do? We don't cancel, or think about it. We just studied a whole unit on this. Yeah, I know they're fractions, but still the rules don't change. What do I do with these x's to simplify? What do I do with the exponents? You subtract them, right? You subtract them. Okay, so same basis. You can write yourself a note if you didn't just know the answer to that question. Same basis. So subtract exponents. So remember, same base, you're going to subtract the exponents. So what's 2/3 minus 1/3? That's a tough one, right? Alright, and then go to this one. What is 3/4 minus 1/4? 1/2. Will those fit under the same radical? One's a cube and one's a square. They fit together? Now the directions are right in radical form, but they won't fit in the same radical. What can I do to make them force it? They're going to fit. What can we do? Multiply by what? Good. Multiply by the denominators, right? If I want them to fit under the same radical, then this is a cube root and a square root. Over here, these are all 4th roots. If I want them to fit under the same radical, their denominators have to be the same. So what should I make the denominator here? Right. So write yourself a note. Get a common denominator. You don't want to forget later. Get a common denominator so they will fit under the same radical. And then you will be like, Miss H, what do I do here? You already know. What's my common denominator? 6. So let's get it. So this becomes a 2 and a 3. Yes, I know you can reduce. If you reduce, you went back to where you started, so don't reduce. Okay? Leave it there. And so now we have the 6th root of x to the squared and y cubed. 6 is not smaller than the 2 and 3, so you're done. Last one we made it. Ready?
Yes.
Nor they. X to the 4/7. First, I would rewrite one thing. Which one of these is not like that? Which one isn't right? Okay, that's true, yeah. What else? Yeah, fix this. What should it be? Y to the power over root. So y to the 3/5. Okay, there we go. Y to the 3/5. Now let's see. We have to subtract. So 4/7 and 3/7 make 1/7. 3/5 and 1/5 make 2/5. The direction we'll put it in radical form, will they fit under the same radical? No, they won't. They will not fit, so get a common denominator. Get a common denominator right here. So they'll fit under the same radical. So you're going to use 35. Instead of 5, instead of 14. Now they're both 35th roots. So the 35th, x to the 5th, and y to the 14th. Can I simplify it? No, the outside radical, the root has to be smaller than the exponent.